Let's try to solve this cryptarithm. That is, let's try to figure out which digits the three letters A, B, and C represent. If we do some detective work here, we'll find that the first clue lies in the fact that we are adding a 2-digit number and a 1-digit number, and we are getting a 3-digit number with B as the leading digit. So does this tell you something about what number or what digit this letter B represents? Well, think about how these letters B and C were generated. They were generated by taking the digit A, or the digit represented by the letter A, and adding to a carry from the previous operation of adding the digits A and B. There must have been a non-zero carry from the previous addition operation, because if there wasn't a carry, then this letter should have been an A, because A plus a 0 would be an A. But since this is a different letter, C, we know that there must have been a carry from the previous operation of adding A and B. Now what could that carry be? At the minimum, the carry must be a 1, and in fact we can also say that at the maximum the carry must be a 1. So the carry must be exactly 1. Why can't the carry be more than 1? Because when we add two numbers, two digits, say A and B, the maximum possible sum that we can get is 18, because if A is 9 and B is 9, then the sum would be 18, and that would lead to a carry of 1. By the way, A and B cannot both be 9 because they are different letters, and so they must be representing different digits. So the maximum possible sum is actually 9 plus 8, which is 17, but even in that case we get a carry of 1. So we never get a carry of 2 or more. So we know that the carry from this operation of adding A and B must be a 1. So we know that the digits B and C must have been created by adding 1 to the digit A, or to the digit represented by the letter A. Now if you think about it, if A was any digit from 1 to 8, then adding a 1 to that digit would not result in a 2-digit number. The only possible way in which you could have a 2-digit number BC from adding 1 to an A is by having A as 9, in which case adding 1 to this 9 would result in a 10. So B must be 1 and C must be 0. So let's replace the letters by these digits and see if the resulting arithmetic exercise is correct. So AA would be 99, B is a 1, and the result would be BCC, or 100. Is 99 plus 1 equal to 100? Yes, it is. In fact, if you are given a cryptarithm, you are guaranteed that after substituting all the digits by the by substituting all the letters by the correct digits, you're guaranteed that the resulting arithmetic exercise must be a correct operation. So this is actually the original exercise from which we had constructed the given cryptarithm. Now in most of the cases, almost without exception, we will find that every cryptarithm has a unique solution. That is, there is exactly one solution to the cryptarithm. So the only possible values that the letters A, B, and C can take are 9, 1, and 0 respectively. There is no other possible combination of digits that can yield this particular pattern.